Welcome to this explainer on the kinetic contrasts of egg rotation. Let's crack into the science, shall we?
Okay, let's dive into a classic kitchen mystery. Why does one egg spin perfectly while another just wobbles?
A hard-boiled egg spins smooth and fast, like a top, but a raw egg, super clumsy and slow. The secret isn't on the outside, though. The real answer hides in the invisible physics deep inside the shell. Let's look at subject A, the boiled egg. It totally behaves like a single solid object.
Since its inside is totally solid, literally every part of it rotates together in perfect harmony.
This perfect harmony creates stable angular motion. Basically, almost zero internal rotational energy gets lost.
Now, things get way more chaotic with subject B, the raw egg. It's totally liquid inside, and that fluid stubbornly refuses to instantly rotate with the outer shell. So you get this chaotic sloshing. Different layers of fluid are literally racing against each other. Now, what's really interesting here is internal friction. It happens whenever varying fluid layers move at different speeds.
Think of this friction as an invisible energy thief, totally stealing the egg's rotational momentum.
You see, that uncoordinated liquid actively rubs against itself and the rigid outer shell.
All that internal rubbing actually transforms the egg's rotational kinetic energy straight into dissipated heat. And that massive energy loss is exactly why your raw egg wobbles and slows down so fast.
Want to see this physics in action? Let's try a super fun, real-world party trick.
Just briefly stop a spinning raw egg with your finger, let go, and watch it spin again.
Here's the punchline. The hidden liquid's lingering momentum actually forces the stopped shell right back into motion.
But try that exact same trick with a solid boiled egg, it stops completely dead in its tracks. And this brilliantly illustrates our point. Solid interiors maintain stable momentum while liquid ones lose energy to friction. So what other fascinating physics secrets do you think might be hiding right now in your fridge?